Okay, this is the potential energy reassessment, and we have a ball that's falling, that was thrown down at 2.2 meters per second. It's going to land on a spring with a spring constant of 5,051 newton meters. It's going to fall 4.4 meters, and the mass of the ball is 10 kilograms. So we're going to make the system, the ball, the earth, and the spring. The work done is going to be 0 because we included every object in the system in our system. So the work is equal to change in kinetic energy plus change in gravitational potential plus change in potential energy of the spring. And we know that the final kinetic energy is going to be 0, the final gravitational potential energy is going to be 0, and the initial spring potential energy is going to be 0. So we get that 0 equals initial kinetic energy minus the initial gravitational energy plus the final spring potential energy. So we get 0 equals negative 1/2 mv initial squared minus mgh plus 1/2 times the spring constant times the distance, the compression of the spring squared. So if we're solving for s, we're going to switch some things around, get s on one side, get s on one side, divide by k, and multiply by 2. We get this here, and then we're going to solve for s, and it's going to be the square root of mv1 squared plus 2 mgh over k. Plug in all these numbers, our spring constant, our mass, our velocity, gravity, the height, all that stuff, and we get the compression of the spring is going to be 0.42 meters.